remember to start recording the meeting. This is fantastic. I'm going to turn my webcam off. And I'll just give you a little brief overview of what we're doing today. And then we have lots of fun things that we're going to practice. So if you don't have a paper and pencil nearby you, go ahead and grab one of those right quick. But for now, believe you can achieve. Hopefully we'll have some time at the end and we can talk about that. Oh, I see a lot of people getting their paper and pencil. I'll wait a second. Hi, Simon. Turn on your webcam if it's working. Okay. Awesome. Looks like most of us went and got our materials so that we're ready. So most of the time in math class, you're going to need, some scratch paper beside you because we're going to be practicing math problems. Okay, participation. You are expected to work on every problem that, we're practicing as a class together, and then you can chat me privately the response. So perhaps it's a really tough problem. Maybe you don't know the answer. You can chat that to me. Or, sometimes we're not always correct. That means if you chat me privately, not everyone can see it, and that's fine. Okay, the recordings. I actually remembered to start recording today, so this is good. On our homepage in 6th grade, I will make a book. I'm sure you guys know what those look like. And it will say, not 5th grade, 6th grade home VC recordings. So you can watch it later, and then, of course, the people who aren't here today. We in 6th grade math have talked about exponents, you've been talking about patterns, you've been looking at multiplication and division of fractions. A lot of you have started some assignments on factors right now, so we're going to talk about those as well. Okay, so if you have, a couple problems that you wanted to talk about today, type in the actual problem. Because when you type in number 15 or number 30, I'm pretty smart, but I don't memorize what number 60 is and so forth. So Ashley, if you have a minute, you can kind of go back and maybe take a look at what those problems were. But hopefully we'll talk about those topics anyway. Okay, so things that you're going to see in the very near future, some of you might have already started these lessons, are properties of factors, prime and composite numbers, and comparing and ordering decimals. So we're going to talk about those at the very end. If we have time, I will take you to a really cool math site. And actually, we might do a couple practice problems from that website. At the very end of class, oops, went a little too fast. You're going to have an assignment for next week's virtual classroom in math. You're going to come with an example of math in real life, and I'll talk about that. I'll give you some pointers. And then for all of our upcoming lessons, I'm going to have each student present one problem next week. So we'll take a look at what you're going to be doing in the upcoming weeks, and each of you are going to go through those lessons, and you can pick one problem that you're going to present to the class. It can be straight off the computer from the lesson itself, or you can make up your own example. That's cool too. Okay, give me a thumbs up if you're ready to get started. Okay, all right, here we go. First thing that we're going to start with is comparing and ordering numbers. So I have a little game. Okay, so comparing and ordering numbers on a number line, and hundredths is way too easy for 6th graders. Let's go up to the millions. So we are going to play a game, and I'll do this very first one for you so you can see how it works, where we're going to order the numbers. So they give us a number. In this case, they gave us 6 million, and I have to put it in the correct place on the number line, okay? So I have to drag the dot. Am I getting cold or hot? Looks like I'm getting warmer. This is a really super easy example. And there you can see. Good job, you placed the dot correctly. All right, we're just getting our brains started, so we're starting off simple. Next problem, 3,600,000. Do I have a volunteer to turn on their microphone and tell me where to place the dot? No volunteers? Oh, come on, sixth graders. I had lots of fifth grade volunteers. They were all over it. All right, Jack. You could just tell me if I'm getting hot or cold.
Cold,
Okay.
cold, warmer, warmer. There.
Right about here? Okay, let's see.
Yeah.
Oh, I dropped it on 2,600,000. So what do I need to do, Jack?
Go one higher.
Okay, go one whole increment higher. So do you think maybe about right there?
Yep.
Oh, I went a little too far. So I'm going to go back. Perfect. See, that wasn't so bad. Let's have another volunteer for the next problem. Oh my goodness, you guys. All right, Kaylee S., it's your big day. We have 8,900,000. Tell me if I'm getting hot or cold.
Cold, warmer, warmer. Right about there.
Okay, you think right about here?
A little bit more.
Okay.
Nope. Too far.
Okay, let's see what it says. Great job. You were perfect. Right on the very first time. All right, we're going to make this harder. Woo, let's go up to the billions. You ready for that? Okay, we have 300 million. So you're going to look at the number line. Here's 0. Here's 5 billion. This is relatively small. Oh, that's a big hint. Okay, who wants to tell me where to place the dot? Excuse me, sorry. Simon, do you want to turn on your microphone and tell me if I'm getting hot or cold?
Let's see, is it on?
Yep, it's on.
Okay, so cold,
Okay,
warmer,
okay,
warmer, warmer,
okay,
and now a little more
okay,
to the right.
okay.
Right about there.
All right. Oh my gosh, you got it right the very first time. That's perfect. So here's your challenge question, everyone. What are each of these increments worth? If this is 0, this has to be blank, and this would have to be blank. So what is each one of these increments worth? My webcam just went out. You can raise your hand or you can chat me privately. It's kind of a challenge. It's not too bad though. If this is 0, this has to be blank, and this has to be blank. So what is one of these increments worth? That's right. Awesome. Ashley, turn on your microphone. Let us know.
Is it on?
Yep, it's on.
I think it's where each one is worth 1 billion.
Well, if it's 1 million, I think it's
No,
actually,
1 billion.
yeah, 1 billion. That's correct. So this would be 1 billion, 2 billion, 3 billion, 4 billion, and then here's your 5 billion, and so forth. Okay, let's do another one. We're in the billions. This is somewhat challenging, but not too bad. So look closely at the graph. We have a 0, and then of course it goes all the way up to 10 billion and 5 billion in the center. So who's a brave soul and wants to place the dot? Oh my goodness. All right. All right, we'll take Jack again, then I'm going to start calling on new people. Tell me if I'm hot or cold.
Is it working?
Yep.
Cold. Cold. Warmer. Right there. A little bit to the right.
Okay.
And there.
Oh, so I'm on 6,200,000,000. So what do I need to do?
Go up a little bit more, about halfway. There.
Perfect. You guys are experts. I want to show you a really cool little trick that I have too. I'm so excited about my pin right now. Okay, I have to pull up this screen. I just learned how to use this pin last night because they just checked it out to me. It's pretty awesome. I don't know if you heard that, but I just took a picture and now check it out. Now I can write on top of this. Hi. All right. How much is each one of these increments worth? Here's a hint. It looks a lot like the last problem. If this is 0 and this is 500 billion and this is 10 billion, yep, you could chat me or raise your hand. Okay. I'm getting a couple replies. That's right, Jack. Good job. So there again, each one of these lines is worth 1 billion. 0, 1 billion, 2 billion, 3, 4, 5 billion, 6 billion, 7, 8, 9, and 10. All right, pretty easy stuff. Oops. Okay, guys, so that was your warm-up. It's going to get a little harder. No, just kidding. It's not that bad. All right, exponents. I'll get good at writing with this pen one day. We'll see. Yay! Okay, first example. We had the fish, and he was a lonely fish, and so the owner bought another fish. So there were 2 fish total. Then every day for 7 days, he doubled the number of fish in that bowl. So how would I write that as an exponent? You're going to have to probably raise your hand for this one because the chat feature doesn't do exponents. Jack. Oh, go ahead and turn your microphone on. Sorry.
All right. 2 to the 7th power.
That's right. So what that means is every day for 7 days, he doubled the amount of fish. So this is what that looks like. 2 times 2 times 2, 4, 5, 6, 7. Okay, pretty easy stuff. This is called exponential notation. Okay, so you need to know some vocab. That's exponential notation. This is called expanded form. I really do write a lot neater than this, but this is expanded form. Now, what we need is standard form, which is really the answer. So I'm going to give you a couple minutes to figure out that answer. And you could definitely chat me the answer. Very nice. I do, Simon. I do see it. Can you chat me privately and then nobody else will see your answers? It doesn't matter if you don't mind people, but sometimes maybe they're not done with the problem yet. Oh, I guess you chose organizer, so I think I am the only organizer, so I guess it would be private. There's another way to choose just me, and either way is fine. It's fine. Yes, it is, Simon. Okay, I'm waiting on maybe one more person, but most of you got it. The answer in standard form is 128. Pretty simple beginning. Okay, we have 3 friends who each bought 3 candy bars. That's quite a bit of chocolate, but whatever. And we want to know what the total of number of candy bars is. So how do I write this in exponential notation? 3 friends each bought 3 candy bars. Somebody new. Three friends each bought 3 candy bars. 3 to the 3rd power. Good. I'm seeing a lot of you write that in your chat to me. So this is exponential notation. Now let's write it in expanded form. Okay, that's expanded form. Now standard form is going to be the answer. Kaylee P. or Christian, do you have the answer to 3 times 3 times 3? Kaylee P.? You could turn your microphone on or chat it. I don't mind. Either way. Oh, I'm not hearing you, so if it's turned on, it's not working. So I would do this problem first. 3 times 3 is 9, and then 9 times 3 equals 27. That's a lot of candy bars. Okay. All right, one more example, and then I will show you a website, and they will give you some practice problems. So you had, all right, Pin, 4 quizzes. Bummer. And each one of those quizzes had 4 questions on it. How do I show that in exponential notation? It's like a couple people are chatting their responses. Very good, Simon. Don't worry about it, Kaylee. I know your microphone must not be on or something. Perfect. 4 to the 4th power. So that's exponential notation. Here's what it looks like in expanded form. 4 times 4 times 4 times 4. So standard form is going to be my answer. What's the answer? 4 times 4 times 4 times 4. I'll give a couple more people a little time. Good, Simon. I would break the problem down. Okay. Couple more seconds. Do I have a new volunteer to go through this problem? All right, Jack, you're not new, but you can go ahead and tell us. What'd you come up with?
I got 246. Is that correct?
It's actually 256, so you might have just added up a little bit, off or something. But for the most part, you probably did the problem correctly. You just added something up wrong. So, yep, 256. Pretty fun stuff. Okay, so we're going to go to get rid of this game for a second. Here we go. Couple practice problems for exponents. Sorry, I should have had this pulled up. I was playing around with it. Wow, there's a ton of different skills. Oh my goodness. Wow. So this is that cool website that I was talking about earlier. Um, Holy moly, you could practice just about anything that you want. Okay, here we go. Yep, all kinds of different skills. What is 0 raised to the second power? Ooh, that's a trick question. How about you can type in, yeah, you could just type in the answer to this one. 0 to the second power. Cool, cool, okay. Looks like most people are saying they want me to vote for 0. Let's see. Very good. 0 to the fourth power. What should I type in? All right, let's see. Okay. 3 to the fifth power. So that might take you a couple more minutes. Excuse me. 3 to the fifth power. I'm actually getting a couple different answers. This is interesting. Take a picture of it. Okay. All right, why are we not working here? Sorry, I have too many. There we go. There's my picture. I lied. I have too many things open. There it is. My goodness. All right. 3 to the fifth power. Oh, wow. I wrote that really bad. Sorry. Okay. Looks like we had a couple votes of 243. We had one person say 125. Lots of different responses. So I think I need to probably show this one. 3 to the fifth power is like saying 3 times 3 times 3. Oh my goodness. Times 3
Fuck, I close it and it comes up again.
times 3. Sorry, those are really bad. So 3 times 3 times 3 times 3 times 3. All right, let's do it together. What's 3 times 3? 9. 3 times 3 is 9. And times 3 more. So 9 times 9 is 81 times 3. Maybe that'll help you out. Give me your new answer. I'll get better at using this pen, I promise. Okay, I'm getting a couple 243s, so that's what I'm going to try. Perfect. Okay, let's do this one a little faster. 3 to the 4th power. Sorry, I lost that page. '81 was correct for that answer, but let's try this one because I lost the other page. 4 to the 4th power. Oh, we've already talked about this problem. This should be quick.
Okay.
4 to the 4th power. That's right. If you were paying attention a couple minutes ago, most of you got that. Yep. One more. Oh, this is easy. 2 to the 0 power. Ooh, maybe it is a trick question because I'm seeing a couple different answers coming my way. This is a trick question, I guess, for you guys. Okay. Most of you want me to say 0. However, that is not the correct answer. Any number to the 0 power is equal to 1. Yeah, so this is kind of a cool website because it will show you what you got wrong. And any number raised to the 0 power equals 1. So this could be 8,535 to the 0 power, and the answer will still be 1. Okay, very cool. We're going to move on here in just a second. I want to see by a thumbs up or a thumbs down who's feeling good about exponents. Pretty easy. Kaylee P, do you have a... Okay, that's a thumbs up. Never mind. All right, here we go. We're going to move on. Practice a couple more. Oh, wow, look at that. Different types of problems. Patterns. So, one of your lessons talked about patterns. You had addition patterns, you had multiplication patterns, subtraction and division, etc. So let me just get your brain going here about patterns. Give you a very simple one. Sorry, that's supposed to be just a comma there. Uh-oh. I am kind of breaking up. I can note, well, sorry about that, guys. I don't know what else to do. Hopefully it doesn't freeze anymore. Okay, so we have 1, 3, 5, 7, 9. Type in the next number. Yeah, that was way too simple. Okay, very good. Let's give you something harder. I'm going to make a table. Try to. Not very good at drawing. Oh. Okay. One, two.
Just a small exam of every like 4 years, every 4 lessons I get one.
This is this street.
Almost done.
This street and trail.
Okay. So on my top row, I have 1, 2, 3, 4, 5, 6. On my bottom row, I have 2, 5, 8, 11. What would be the next number that goes right here? Yes. Perfect. So this is very simple. What was I doing in this pattern? What was the pattern? That's right. I was adding 3. Okay. Here's a challenge for you. Did anybody come up with, because I think you had to come up with your own pattern. Does anybody remember the pattern that they had? And then we can try to solve them? Okay, Kaylee, how about you type it into my chat privately and I'll write your pattern out and everybody else will try to solve it. Oh, Kaylee S. Okay, she's typing her pattern to me. Hopefully it's a hard one. Okay, I have one example. So Kaylee's still working. Here's one. Try to figure that pattern out. 5, 8, 6, 9, 7. What would the next number be? And then you can tell me what the pattern is. Okay, yeah.
Hey,
All right.
Dad.
Jack, turn on your microphone and tell me what the pattern is.
The pattern is add 3, subtract 2.
Perfect. These are way too easy for you guys. I think there might be some harder examples on this website that we were just on.
Is that correct?
Yeah, that's correct. That was right. Let's take a look.
It's squares, probably 20 plus 25 times 25. I think it's 500.
Wow, there are way too many things here to look at.
Squares. What's 5? That's not right though. 25 times 25 is not.
Okay, I hear somebody in the background. Maybe you can turn off your microphone.
Is that you?
I think so.
Sure.
Okay, I'm going to come back to this in a second. Wow, there's way too many things for me to look at there. Okay, here we go. Another skill that you guys worked on was the commutative and associative property. That is very simple. I'm just going to do a really quick little overview of that, and then we'll move on to the distributive property and factors because I really want to play a game called Factor Tree. Okay, commutative property. Who wants to turn on their microphone and tell me actually what it is? I'll write an example and then you can tell me what the property is. That's an example. Okay, Simon, your microphone's back on. Do you want to tell us what the commutative property is?
It's whichever way you write an expression, the answer is still the same.
That's correct. So this is very simple, guys. 2 plus 3 is the same thing as saying 3 plus 2. And that can be translated into, bigger numbers like 4,000 plus 6,500. That is the same thing as writing 6,500 plus 4,000. I'm not going to spend any more time on that because that is too easy for sixth graders. I couldn't believe that was even in your lessons. Associative properties, maybe slightly harder, but not really. Okay. All the associative property is telling you is in addition, you can put your parentheses around any two numbers and do that problem first, and it's still going to give you the same results. When you see parentheses, guys, that is a clue that you are supposed to do that problem first. So 2 plus 4, of course, is 6. 3 plus 6 equals 9. Here's my parentheses. I have to start here. 3 plus 2, 5 plus 4, same answer is 9. And you are very correct. Somebody just told me that that particular property works in multiplication as well. Let's test it. Okay, so all I did was use the exact same numbers. I just put the parentheses around two different sets of numbers in the first and second problem. Ashley, that's okay. I'm not sure why you're not able to hear us right now. Maybe check your speakers, see if they're turned up. Yeah, I'm not sure what's going on there. Okay. Who wants to walk me through this problem? Very simple. I'm going to take somebody I haven't heard from today. Christian, can you turn your microphone on and tell me what 3 times 2 is?
Six.
That's right. Christian, what's 6 times 4?
24.
Perfect. And then, Christian, what's 8 times, I'm so, whoops. What's 4 times 2?
8.
Very good. I gave you the answer there. What's 8 times 3?
24.
Perfect. So there you go. The associative property works in multiplication as well. Okay. We're going to look for an example of the distributive property. Slightly more complicated, but not much. If anybody sees it as I'm scrolling up, tell me, because there's so many. Wow. Look at all this. Where are you? Only when you really need it. Anybody see it yet? Distributive property? Probably not, huh? Oh my goodness. I'm going to have to take a couple minutes and find that because there's just way too many. For now, let's skip ahead to our game. Wow. Okay. Sorry about that. But I'm sure you're not upset about playing a game instead. Factor tree. Okay. So most of you have already started this assignment, not everybody. Yeah, I know, I didn't see it. Did you? Well, if I see it here, Simon, I'll pull it up in just a second, but I didn't see it. Okay, factor tree. Here it is. So most of you have started your work on this. Before we get started playing the game, somebody just turn their microphone on, raise their hand, and tell me what a factor is. Because that's important to know before we play a game. What is a factor? Ooh, math vocab. Simon.
A factor is a number that's multiplied by another number to create another number.
Yes, and a factor is also a number that has no remainders, so it can be divided into equal parts. Okay, so a prime number, for instance, cannot be divided into equal parts. The only factors that a prime number has is the number itself and 1. I kind of got ahead of myself there, but a factor can be divided into equal parts. Okay, so, oh, this is easy. Who wants to do this very first example? Ashley.
2 times 2.
Okay. Perfect. Oh my goodness, that was simple. Oh, this one's slightly harder, but not much. The factors of 36. What number times itself equals 36? Jack.
Um, 6.
That's right.
6.
That's right. Oh, look, it split it again. What number times itself equals 6? Christian.
3. Wait, no.
This is as far as your factor tree is going to go. So, what 2 numbers can I multiply by themselves to get 6? Should I try 2 times 3, or do you want me to try 1 times 6?
2 times 3.
Okay, let's try that. Oh, good. That was one of our answers. What is another way to come up with your answer of 6?
1 times 6.
That's perfect, yeah. Oh, use a different number. So they don't want us to use that. Maybe, okay, they just wanted us to show that 2 times 3 is the same thing as 3 times 2. Perfect. Let's make it a little harder. Oh, that's not too much harder, but okay. Factors of 20. Ooh. What could I type in here for factors of 20? Let's have Simon.
5 and 4.
Okay. Oh, perfect. Do you notice what it did right here, guys? It stopped. There are no factors for 5 because it is one of those numbers I was telling you about called a prime number. The only thing that you can multiply to get a 5 is 1 times 5, and that's it. So that's why it stopped. However, there are some factors for 4. Who wants to give me those? Kaylee P. Yeah, you can hold up your fingers if you're, okay, perfect. 2 times 2. That's exactly right. Notice it stopped here because you cannot go any farther. The only thing you can multiply together to get a 2 is 1 times 2, and that's it. Okay, factors of 8. Christian, why don't you tell me how can I, or what 2 numbers can I multiply together to get 8? I'll give you a hint. Here's one of them.
4.
4 times 2. Perfect. Okay, notice it stopped right here because I'm done with the number 2. However, 4 has more factors. So what should I put in these 2 boxes?
2.
Good. Oops, I don't know why that didn't type, but perfect. Oh, look at this, a Venn diagram. Factors of 20, common factors that they both share, and factors of 8. I'm going to take a screenshot of this and write on top of it here in a second. So give me just a minute to take a screenshot. Okay, that should work now. Okay, factors of 20. So anything in the yellow are only factors of 20. Anything in the green are factors or numbers that they both share, both of these problems. And factors in this blue color are only factors of 8. So who wants to help me fill in factors of 20? Which numbers are only factors of 20? Jack? That's right. Yep, he just sent it to me in the chat. 5 works because 5 is only a factor of 20. You do not see it over here at all, right? It has nothing to do with the number 8. Are there any other numbers that are only a factor of 20? You guys could type them in. Perfect. Yes, I saw another good example. 10 is also a factor of 20. It's not shown in our factor tree, but it is definitely a factor of 20. Yep. Good. What are some factors that they both share? Both 8 and 20 share. Good. 2. They both share 4. Perfect. Any other common factors between 8 and 20? I think that's it. Oh, 1. Yeah, okay. Factors of 8 only. Probably just 8 itself. Yep, that's right. Because all of the other factors, it looks like, can still apply to the number 20. So, very fun. That was pretty cool. So this is kind of what you're working on right now. You should be working on factors this week. You are going to be comparing and ordering decimals very soon. So I'm going to go back to our agenda. It's actually okay that I didn't find what I was looking for on that one site because we're running out of time. Okay. Okay, here we go. For next week, next Thursday, for our next Math VC, I want you to come with an example of math in real life. So for instance, with 5th graders, we were adding up numbers and that kind of thing. So we talked about going to Target and not having enough money to pay for everything that I put in my cart because I was paying with cash. That's an example of real math in real life. So I want you to be maybe a little more specific than that. Like I went to the store and I bought this, this, and this, and they cost, this amount. But it can be, yes, it can be an example like baking has math involved. There's lots of different examples. Just adding up maybe the amount of calories that you're going to eat when you're looking at, the wrapper on your 3 different candy bars that you bought at the movies. But so one example of math in real life. And then your upcoming lessons, you're going to be working on, well, this is kind of what you're working on right now. Factors, prime, and composite numbers, and ordering and comparing decimals. I'm going to take volunteers first, but I'm going to have you guys come with one problem from each of these topics to teach the class next week. So do I have any volunteers to show us a factor problem next week? You could just raise your hand because I can see you. Okay, so this will be Jack. Do I have any volunteers to show us an example of a prime or composite number? Very good. And it's not like you have to go out into the world and find these problems, guys. This is actually in your assignments. So you could take a problem that comes directly from your assignment, or you can make up your own. That's fine too. Do I have any volunteers for comparing and ordering decimals? Okay. Like I said, you don't have to go and find something. They're going to be in your lessons. Okay, Ashley, I'm going to have you also find a factor. Example, Christian, you're going to find an example of prime and composite numbers. So we're going to have the 2 Kayleys. There we go. Find examples of ordering and comparing decimals. Give me a thumbs up if that's okay. Sounds good. It's actually very easy. Cool. You guys were fantastic today. Let's just go back to the very, very top because we have 2 more minutes that we can talk about this. Believe you can achieve. What does that mean to you? Go ahead and type that into your chat. Ooh, I already got 1 response. Wow. Yes. Oh, I can't keep up. Okay. That's right. Okay. Very good. It means you can do anything that you put your mind to. You have to believe that you can do something and believe you can do anything at all. Anything is possible, guys. I will tell you that from personal experience. So, all right, I'm going to turn my webcam on so I can say goodbye to you all. It was a lot of fun. Don't forget, these files do take me a while to convert into YouTube videos, but on our homepage, I will make a book and post them. All right, let me turn this video on. Oh, darn it, all webcam spaces are currently being used. Darn, you guys don't get to see me. But I'm waving to you in spirit, so it was fun. I'll see you later. Bye.